All right, number 26. Keyes modeled the growth over several hundred years of a tree population by estimating the number of trees population grains per square centimeter that were deposited each year within the layers of a lake sediment. He estimated there were 310 pollen grains per square centimeter the first year the grains were deposited, with a 1% annual increase in the number of grains per square centimeter thereafter. Which of the following function models P of t the number of pollen grains per square centimeter t years after the first year the grains were deposited? Okay, so pretty much we know is started with 310. Okay, so 310 pollens per square centimeter. And then each year after that is an increase of 1%. Okay, so what we have here, this is gonna be an exponential model, and we can see in the answer choices, right? Oh, these are exponential as well, because our variable is in the exponent, right? Okay, so for an exponential model, we know the general form that we can use is y equal to a times b to the x power. That's like the general structure of the exponential model. Okay, and the a value is always going to be the initial amount. Okay, so that's a number that we started with. Okay, number that we started with. So in this scenario, in this question, the number should be 310, right? That's the number that we have in the very first year. So that should be 310 in front. Okay, and then y here, we'll just say this is p of t, is same thing. Okay, so p of t is just a function notation, is representing the y value pretty much. And then in the parentheses, this should be either the growth factor or the decay factor. So in this case, okay, we have a 1% increase, but we cannot put 1% inside the parentheses. Okay, because 1% is only representing the amount of increase. And this whole model represents the total number of the grains, right? It's not just the increase, right? It's a total number. So what we had to do is we had to add it to 1. Okay, so it's like a 1% increase, you had to add it to 1. So it'll be 1 plus 1% pretty much. Okay, and 1 is like equal to 100%, right? So we add it to 1. But then the 1% we also had to convert to a decimal is 0.01. So it'll be 1.01 when we add. Okay, and this is same as 101%. So pretty much after 1% increase, now the new number should be 101% of the previous number. Okay, so the growth factor is 1.01. Okay, that's what we need to multiply to go from one number to the next. Okay, and raised to the x, and for most of the exponential model, x represent time, right? So in this case, that's a number of years. Okay, so number of years, so it'll be t years, so it'll be t in the exponent. Okay, so which answer choice is correct? Right, it had to be letter D. Okay, yes, so you want to remember the general structure for the exponential model, and then want to know what each part represent, and then plug in from there. Okay, and that should be our answer.